Hi Year 12 Maths General students. We're continuing with Unit 4 in this lesson, looking at using the compound interest formula to find the differing variables within the equation in different scenarios. So the lesson objectives for this time around, we're going to review the compound interest formula from when we covered it in Unit 1 and 2, and particularly the importance of converting the I and the N values to incorporate that compounding period K. And then we're going to look at some different scenarios where we have to find either A, P, I or N values. And if you can remember back to when I covered this in Unit 1 and 2, I like to modify the formula a little bit because I think it's easier to use if you show the conversion of I including K, and then N is your time in years, also incorporating the compounding periods K. Okay, so we're going to do a bit of a refresher where we look back on what we learned in Unit 1 and 2 when using the compound interest formula in basic loan or investment scenarios. So again, you're lucky enough to have this formula on your formula sheet. However, I like to modify it a little bit so it's easier to use if I'm showing myself with my decimal interest value. I need to convert it into decimal form and also incorporate the K or compounding periods per year. Additionally, for the N, I like to show that we convert that using the time in years and the number of compounding periods. So to start with, because it's really important that we convert our I and our N values to use it correctly in the formula, I'm just going to do a quick refresher on using those K values. So commonly used time periods that we've looked at before: quarters, months, fortnights, years, and very rarely days. So the next part's going to be looking at the quick refresher on finding I and N values. Alright, so the example question we have to use to practice this skill is we've got a 5-year loan and we're given a nominal interest rate of 5.5% per annum. And we want to practice converting the I and N values to use if we have monthly compounding periods, fortnightly compounding periods, and quarterly compounding periods. So I'll work through monthly and then I'll get you to pause the video and have a go at calculating the fortnightly and quarterly values. I would always start by writing down the given values. So for our I, it's 5.5% per annum. For the time, it's 5 years. And for a monthly, we want 12 as our K value. So for our conversions, we use the formula, our given interest rate, 5.5 over 100 by K. And when I calculate that, pull it up on my calculator, enter it in. Be careful with the 100 by K bit, use brackets. So that's 0.004583. Okay, and for the N value, that's simply your time by your K value. So we've got 5 years times 12 compounding periods per year, which will give us an N of 60. So pause the video, have a go at doing fortnightly and quarterly, and we'll check in a second. How did you go? Hopefully for the fortnightly, you got a decimal interest of 0.002115 and an N of 130. For quarterly, a decimal interest of 0.01375 and an N value of 20. Okay, so now we get into the fun part. where we're applying some compound interest loan or investment scenarios, and we're looking at how we can find the different variables within that formula. Okay, so I've put together 4 examples, each one finding a different variable within the formula. Question 2 is looking at finding the A, or the balance in an account. Question 3 is looking at finding the initial balance, or the P value. Question 4 is looking at finding I, or the interest rate. And question 5 is finding the N value within the formula. You'll also notice that I've rated the question as simple familiar or complex familiar, where the simple familiar, there's just essentially a simple number of steps it takes to get to those variables. And with I and N, the process is just that little bit more complex, where we need a few more steps to get to the answer. For all of these questions, the essential skill that you need to have is being able to substitute the right values into your formula, and then using your fabulous solving equation skills, working towards isolating the variable that you're after to solve for it. Okay, so we're going to start off with example 2. We've got Rachel investing $5,000 into an account that earns interest at a rate of 4.5% per annum, compounding monthly. So again, making sure you get into the habit of identifying the values you're given. So the 5,000 is your P value, your 4.5% is going to be used for our I value. Our compounding monthly, that tells us our K is 12. So good habit means that we rewrite down the given values, and let's start with part A. They want to know how much is in your account after 3.5 years. So that extra bit of information is our time is 3.5 years. So now I have all the information I need. It's just a simple matter of substituting everything that I have into my compound interest equation. And then plugging all of that into the calculator. I like to start with what's in brackets first. So I just put in the 1 plus 4.5 divided by 100 by the 12. Okay, then I'll work with indices next. So as you can see, I'm following the BIMDAS protocol. So I put it to the power of 3.5 by 12. And then finally do the multiplication. And that gives me a total balance of $5,851.18, because you round to the nearest cent. Okay, addressing part B, we want to know the amount of interest she's earned. So if you remember, interest is always the final minus the principal when it comes to these compound interest questions. So the 5851.18 minus the $5,000 means she earned interest of $851.18. Let's look at question 3. Final value paid out on a loan was $8,000, taken over 3 years at an interest rate of 3.6% per annum, adjusted, which means compounded, fortnightly. Determine the principal amount borrowed. So again, I would go through and highlight the information we're given. So the $8,000 this time is the final balance. 3 years is our time. 3.6% is the given interest rate. compounded fortnightly is our K value, 26. We've got to find this time around the principal. So again, I would just not worry about rearranging the equation. I'd simply substitute in all our known values and then using our solving equation skills, eventually get to our p-value by using that reverse BIMDAS process. As always, good practice, write down your facts and then substitute everything into the formula. From there, evaluate what you can. So we can pull out the old calculator again. Let's work out what's inside the brackets. Put that to the power of 26 by 3. So we can write down that this part here evaluates to 1.14. Okay, so from there, it's just a matter of solving a simple equation for the variable p. So to move this times 1.114 to the other side, or divide by 1.114. And we can evaluate what p is. So it looks like the start of the loan, this person borrowed $7,181.33. Okay, so hopefully you found that easy. Now let's move on to question 4. Okay, so we have Bob taken out a loan from a bank of $15,000 over 10 years, which compounded monthly. A total of $21,921 was repaid back to the bank. We need to determine the interest rate he was charged from the bank. So first steps would be identifying the information we got given. Okay, it's going to be 12. That's our final balance. We want to know the interest rate. So looking at our equation, this is our target. Always document the values you get given, and then let's substitute it into the formula. Don't know I value time 10 by 12. Okay, from there we'll evaluate what we can. And then hopefully it'll make it a lot easier to get to our unknown when we're solving equations using that reverse BIMDAS process. Okay, so now I've evaluated what I can using my reverse BIMDAS. I need to think about, is there any addition or subtraction outside of brackets? No. Is there a multiplication or division? Yes. I've got the 15,000 multiplying whatever's in brackets. Then I have indices, the 120 is it the indices I need to move over. And then finally I can deal with what's in brackets. So we'll go through that process now. Okay, so I'm going to move multiply 15,000 by dividing 15,000. both sides. Okay, so 21,921 divided by 15,000. So that's 1.4614. Okay, so I need to get rid of the indice next. So we know the opposite operation to the power of something is the nth root of something. So I'm going to do the 120th root. And remember, on your calculators, you need to access this part of your calculator here to put that value in. Okay, so the way we write it is we want the 120th root of 1.4614, and that will give us our access to what's in the brackets now. So to put that in the calculator, we'll go the 120th root of 1.4614, and that's 1.00317. Let's round it to. Okay, now that we've gotten rid of the brackets, we can start with our reverse BIMDAS again. Now looking at that, do I have an addition or a subtraction? Yes. So I'm going to get rid of the +1 first. Then finally I can move on to get rid of the divided by 1200 division. Okay, so we'll subtract 1. And to get opposite to divide by 1200 is to multiply by 1200. And we will have our I value. So 3.8% per annum. Okay, let's do the last question. Okay, so question 5 is probably the trickiest type of variable you have to find within the compound interest formula. So it's an example of finding n, but what we're really after is the time within n. So I think it's easier using this modified equation to do that. So you're telling yourself to incorporate the k value. Reading through the question, an investment of $2,500 was made at an interest rate of 6.5% per annum, adjusted quarterly. Determine how long it will take the investment account balance to exceed $4,000. So again, good practice to go through and identify the values we're given. So principal of 2,500, interest 6.5% per annum, adjusted quarterly. Case 4, how long? We're after the time in years, and it's going to exceed $4,000, so this is our A value. So we want an A value that's greater than $4,000. Okay, so document all your values, and then we're going to substitute everything that we know into the formula. Now just note that I've written down that we need to find an A value that's greater than 4,000, but for the purposes of this exercise, to make it easier for ourselves, we'll just set the A value to 4,000, and know that the time period I find has to be a little bit more than whatever value I find for t. Okay, so from there, we're going to evaluate what we can. There are two common methods you could use to find t. Now, the Maths General syllabus promotes a trial and error method, and that's the only method you need to be able to use to find the t value. However, many students come over to Maths General from Math Methods, and you would have covered using a method using logarithms, which help you identify the value of an unknown variable that's an indice. So we're going to look at both methods just because those two methods are available and they're both correct methods of being able to find your t value. Using the first method with trial and error, essentially what we're doing is we're trying to substitute values in for t in order to get our right-hand side to agree with our left-hand side. So you're going to trial values by putting into your calculator the right-hand side, and to start with, you can do like checks. So I'm going to start with trying 5 years. If it's too much, I'll knock it back. So let's enter these values into our calculator. And we're going to try t as 5 years. Let's see what we get. $3,451.05. So that hasn't exceeded $4,000. So that means my t value must be more than that. So trying t is 10 years, so I'm just trying 5-year increments. Now instead of retyping it all in your calculator again, if you simply press replay to the left, it will take you up to your input that you just added, and you can simply just replace the 5 with a 10, and that will pump out the balance after 10 years. Now you can see that this balance has exceeded $4,000, but we still don't know when it exceeded $4,000. So it looks like we need to step it back a bit to check between which year did it exceed $4,000. Okay, so I'm going to step it back to 7 years. Let's check that. So it still hadn't exceeded in 7 years. I'm going to try 8 years. So I'm refining it. Somewhere during that 8th year, it's passed over that $4,000. Okay, so after the 7th year, we had a balance of $3,926.05. And then by the end of the 8th year, we'd have a balance of $4,187.53. So a concluding statement would say something like, in the 8th year, it exceeds $4,000. So we're going to address the second method where you can use logs to solve for t. A really simplistic explanation of logs is they allow us to access indices, particularly those indices that we don't know the value of them. And essentially, to access them, when you take the log of both sides of an equation, it pulls down indices to be at essentially the same level as the other numbers, so it's no longer an indice. So I'll show you what I mean. Remember, this is just a really simplistic explanation. We're not going into the whole mathematical background of using logs. I'm just simply showing you how to use them on your calculator to access an indice. So the first thing we need to do is we want to move over that 2,500 to the other side. So we're going to divide by 2,500. Which gives us 1.6. Okay, and this is where the log function on your calculators can be used to help us access that indice. So really simplistic explanation, and this does not take into account any log theory, is by taking the log of both sides and what you'll do is you'll access your calculator and you'll use this log button. Okay. What taking the log essentially does is it brings down the indice to the same level as the other numbers to become a multiply. So then I show that I've taken the log of both sides. And I show that I've brought down my indice. And then from there, I'm just applying my reverse BIMDAS to move everything over to the other side of the equation to isolate my t value. So because I've got multiplies there, I'm going to move them. So I'm going to choose to move the times log 1.0625 first by dividing. I simply enter them into the calculator as they're written. So log 1.6 divided by log 1.01625 and evaluate that. So it's got 29.16. And then lastly, getting rid of that times by 4 by dividing by 4. Shows that I have 7.29 years. So you can see that's a more exact answer than the trial and error. And if you think about it, that means 7 years has passed and I'm 0.29 into the next year. So when I've got to be careful when I write my response there because it's already 7 years after, I'm into the 8th year. So again, you would say something like, in the 8th year, it exceeds $4,000. Okay, so that's probably the toughest type of problem. You can see there's two ways to solve for it. Those confident using logs, go for it. Those that just prefer the trial and error method, that's also okay. So hopefully you feel a little bit more comfortable using your compound interest formula. So we looked at how to convert your N and I values that you need to use for your given compound interest formula and then hopefully it gave you a bit more confidence with solving for different variables within your compound interest formula. Thanks, Year 12s.